The signal that arrived at the Canberra antenna on a Tuesday afternoon in 2024 had taken 22 hours and 38 minutes to get there. It was traveling at the speed of light. It had come from a spacecraft moving at 38,000 miles per hour, 15 billion miles from the people who built it. And the numbers it carried did not match the numbers anyone had predicted. Voyager 1 was where it was supposed to be, roughly, but the velocity residuals, the tiny gap between what the model said and what the spacecraft was actually doing, were not zero. They were small, they were stubborn. They had been growing quietly for years. And the engineers who could still read the raw telemetry were starting to notice that the most famous spacecraft in human history was, very gently, being pulled. That is the part that should bother you, not the headline. The headline says Voyager is leaving the solar system. The data says Voyager is leaving, but not in the direction the math allows. And nobody at the agency that built it is willing to say that out loud, because the moment they do, every textbook that launched it becomes a textbook that needs to be revised. Wherever you are watching this from, think back to when you first heard the name Voyager. School, probably. A diagram with a clean arrow pointing out of the solar system. Did anyone ever tell you that the trajectory was a settled question? Because for 47 years, that is exactly how it has been sold to you. In 2012, when Voyager 1 crossed the Heliopause, NASA expected the magnetic field on the other side to be oriented differently from the field inside. It wasn't. The orientation matched. That finding has never been fully explained. In 2023, Voyager started sending back structured gibberish, telemetry that looked like data but decoded into noise. JPL spent months reverse engineering hardware untouched since Jimmy Carter was president. The press release said, solved. The engineers said, worked around. Those are not the same word. And at the same time, the tracking team was noticing something else. The Doppler shift coming back from Voyager was drifting, by the kind of number that, at 15 billion miles, is the difference between physics being complete and physics being incomplete. This is not new. In the 1990s, Pioneer 10 and Pioneer 11 showed the same thing, a tiny sunward pull that defied gravity. 3 decades of debate. A 2012 paper claimed thermal recoil explained it. The case was officially closed. Now Voyager is showing residuals in the same direction. Sunward. Small. Stubborn. The most distant object humanity has ever built is the messenger telling us the map is wrong. The official story is that Voyager is leaving. But leaving where? And being pulled by what? The public version of the Voyager story is one of the cleanest narratives in modern science. 2 probes launched in 1977 took the grand tour and kept going. Voyager 1 crossed into interstellar space in 2012. Voyager 2 followed in 2018. The mission is, by every public measure, a success. That is true, and it is also the part of the story that does the most work to hide the part that isn't. Go to the official Voyager status page. The language is curated. It gives you distance, velocity, round-trip light time. It tells you the spacecraft is healthy. It does not tell you that the trajectory ephemeris, the predicted position file that JPL publishes, has been quietly revised more than once in ways that are not flagged in any press release. The public sees a clean number. The internal teams see a number with footnotes. The Pioneer Anomaly was a sunward acceleration of 8.74 times 10 to the negative 10th meters per second squared. A number so small it sounds like a rounding error. Over 30 years of Pioneer 10 tracking, that tiny pull added up to a position discrepancy of about 400,000 kilometers. more than the distance from Earth to the Moon. Here is the part that should bother you. When Voyager was launched, the tracking precision was deliberately set lower than what would be needed to detect an anomaly that size. Why? Because Pioneer's drift was supposedly already explained. The instrument was calibrated to confirm a conclusion already considered settled. Then there was the 2012 Heliopause crossing. NASA had a model. The model predicted the magnetic field orientation would shift across the boundary. It did not shift. The fields matched. That was not a small finding. It suggested the heliosphere is shaped differently than every textbook diagram you have ever seen. Voyager 2 crossed in 2018 and showed the same thing again. Add the 2023 attitude control glitch, officially solved, root cause unstated. Add the 2024 memory corruption, officially solved, root cause unstated. Both reported as engineering wins. And they were. The team kept the spacecraft alive. But we kept it alive, and we understand why it almost died are not the same sentence. The mission is going well at the engineering level. At the physics level, it is something else. The spacecraft is healthy. The model around it is not. And when the agency quietly revises the trajectory file and quietly republishes the numbers and does not flag the revision, the public is the last to know the map moved. If the gravity model is right, Voyager should be here. It isn't. So either the model is incomplete, or something we haven't named is doing the pulling. To understand why a tiny anomaly is such a serious problem, you have to understand what the trajectory is built on. And what it is built on is a set of assumptions that have been tested rigorously inside the solar system, and almost not at all outside of it. The equation that predicts where Voyager should be is, at its core, the same equation Newton wrote down in 1687, updated by Einstein in 1915. It assumes you know the mass of every object pulling on the probe. It assumes you know where those objects are. It assumes space between them is essentially empty. Inside the solar system, those assumptions are spectacularly accurate. We have landed rovers on Mars by trusting them. We have threaded probes through the rings of Saturn. The math has earned its reputation. But here is the part that should bother you. The math has only been tested out to about 60 astronomical units, roughly the orbit of Pluto, with the precision needed to detect a Pioneer-sized anomaly. Voyager 1 is at more than 160 astronomical units, almost 3 times beyond the verified range. Imagine a ruler calibrated against a known standard for the first 12 inches. Past 12 inches, the markings continue, but nobody has ever checked them. The ruler might still be accurate. It probably is. But probably and verified are not the same word. Now layer in the other forces. There is solar radiation pressure, the gentle push of photons, falling off with distance but never reaching zero. There is thermal recoil from the RTG, the plutonium generator that keeps the electronics warm. Heat radiates off the spacecraft asymmetrically, creating a tiny thrust. Both are modeled. Both models depend on assumptions about the spacecraft's surface that cannot be checked at this distance. We are modeling forces we cannot measure on a vehicle we cannot inspect, and subtracting those forces from the observed trajectory to look for what remains. What remains is the anomaly. The heliopause is the wall where the Sun stops pushing back. Voyager crossed it in 2012. The moment it did, every assumption about what space is made of on the other side became an extrapolation. Nobody has ever measured the interstellar medium directly. Nobody except Voyager. Here is the translation. Gravitational potential is not an abstract equation. It is the invisible slope the spacecraft is rolling down. The heliopause is not a line on a diagram. It is the wall where the Sun stops pushing back. And Voyager is rolling down a slope nobody has ever measured directly. If the model holds, Voyager is coasting. If the model doesn't hold, if there is even one mass, one field, one force we haven't accounted for, then Voyager isn't coasting. It's being steered. Here is the precedent that should have changed everything, and didn't. In 1972, NASA launched Pioneer 10. A year later, Pioneer 11. By the late 1990s, the team analyzing the radio signals coming back noticed something that should not have been there. The spacecraft were decelerating. By 8.74 times 10 to the negative 10th meters per second squared, pointed back toward the Sun. An acceleration so small you could not detect it inside Earth's orbit. But over billions of kilometers and 3 decades, it added up to a discrepancy nobody could explain. The first papers came out in 1998. John Anderson and his JPL colleagues. They checked everything. Solar radiation pressure, gas leaks, software errors, planetary ephemeris errors. Nothing accounted for it. The acceleration was real, sunward, and present on both spacecraft at the same magnitude. 2 independent probes, separated by years of launch, traveling in different directions, showed the same anomaly. That is not noise. That is a signal. For 30 years, this was an open wound in physics. Serious papers proposed modified gravity. Serious papers proposed dark matter halos in the outer solar system. Serious papers proposed we had missed a force entirely. Then in 2012, Slava Turashev and his collaborators published a paper claiming the whole thing was thermal recoil. Heat radiating asymmetrically from the spacecraft, producing a small thrust pointed sunward. The math, they said, fit. The case was closed. Here is the part the public never heard. The thermal model depended on a finite element simulation of how heat moved through the spacecraft. That simulation depended on assumptions about surface emissivity and the orientation of every reflective surface. Assumptions that could not be verified because the spacecraft was not coming back. Several physicists pointed out, in peer-reviewed responses, that small changes to those assumptions could erase the explanation entirely. The community accepted the resolution anyway, not because the evidence was overwhelming, because the alternative was admitting we had an unexplained force in the solar system. Now think about Voyager. The Voyager spacecraft were built by the same teams in the same era, with the same plutonium generators and the same asymmetric heat radiation. The original tracking precision was set lower than Pioneer's, deliberately, because Pioneer's anomaly was supposedly solved. So the instrument was not calibrated to find one. But recent reanalyses, going back through decades of Voyager Doppler data with modern processing techniques, are showing residuals that are not zero. Small, stubborn, sunward. When a scientific community needs an anomaly to be solved in order to keep funding the next mission, the anomaly tends to get solved on paper before it gets solved in the data. That is not a conspiracy. That is institutional pressure. And it is how a 30-year mystery becomes a closed case in a press release, while the underlying physics quietly stays open. If Pioneer's drift was real and we explained it away, then we are flying Voyager into the same unknown with the same blind spot. And this time, we are 15 billion miles in. I want to give you a number and then show you what the number actually does. The Pioneer anomaly was 8.74 times 10 to the negative 10th meters per second squared. Voyager's residuals are in the same order of magnitude. The point is the size class, small enough that a casual reader would dismiss it as rounding error. Here is the part that should bother you. At Voyager's launch speed, that acceleration is invisible. After 1 year, it has shifted the spacecraft's position by about half a kilometer. Trivial. After 10 years, 50 kilometers. After 47 years, it has added up to a position discrepancy on the order of 1 to 200,000 kilometers. Roughly half the distance from Earth to the Moon, applied to a spacecraft now further from us than any object humanity has ever built. The acceleration did not get bigger. The spacecraft got further away from anything that could correct it. Inside the solar system, you can spot a tiny anomaly and dismiss it because 100 other forces are larger. At Voyager's distance, there are no other forces. The sun's gravity is a whisper. The interstellar medium is nearly empty. Every small force becomes the only force. The signal-to-noise ratio inverts. This is the rule that breaks human intuition. We assume a small problem stays small. A 1% error in the early burn of a Mars mission becomes a miss of millions of kilometers by arrival. Errors compound. Time amplifies. Distance reveals what proximity hides. Now scale that forward. If the same tiny acceleration we cannot explain on Voyager is acting on every spacecraft, every planet, every star, and we just could not detect it until we put an instrument out far enough where nothing else competes, then we are not looking at a Voyager problem. We are looking at a physics problem. This is exactly where the modified gravity debates live. MOND. Dark matter alternatives. The question of whether Newton and Einstein give us the complete picture at scales much larger than the solar system is one of the most contested questions in physics right now. Galaxies rotate faster than their visible mass allows. Galaxy clusters bind more tightly than gravity predicts. The standard answer is dark matter, a substance that interacts gravitationally but has never been directly detected. The alternative is that gravity itself behaves differently at large scales. If Voyager is showing an unmodeled sunward pull, and if that pull is consistent with a gravity that strengthens at large distances, then Voyager is not just a spacecraft anomaly. It is a possible smoking gun for the same physics that explains why galaxies hold together. The question stops being, what is pulling Voyager, and starts being, is whatever is pulling Voyager also pulling everything else, and we just couldn't see it until we put a probe out far enough to notice? Now I want to take you off the spacecraft and put you in the room with the people listening to it. The original Voyager team came together in the early 1970s. Engineers fresh off Apollo, building hardware for a mission supposed to last 5 years that went on for nearly 50. Many of those people are now in their 80s. Many are no longer alive. The institutional knowledge that built Voyager exists in a shrinking pool of human minds. Suzanne Dodd has been the Voyager project manager since 2010. In interviews, she has been quietly direct. They cannot easily hire new engineers because the skills required do not exist in the modern workforce. The flight data system runs on a custom 1970s architecture. The code is in a dialect of assembly nobody teaches anymore. The hardware diagrams exist on paper, in binders, in a building at JPL that smells like archival storage. When the 2024 memory corruption hit, the team had to reverse engineer their own spacecraft from documentation untouched in 40 years. They called retired engineers. They opened cabinets unopened since the Reagan administration. They solved it. They got the spacecraft back, and in solving it, they revealed something nobody had quite said out loud. The spacecraft is now smarter about its own internal state than most of the engineers who can still read its messages. It is sending letters home in a language fewer and fewer people can read. A signal arrives at the Canberra antenna in Australia, one of 3 deep space network sites that can hear Voyager at all. The signal has traveled for 22 hours and 38 minutes. It is so faint that the receiver has to integrate it over time just to pull it out of cosmic background noise. The total power received from Voyager's transmitter after 15 billion miles of inverse square law is less than 1/10,000,000th of a watt. The engineers read the telemetry. They flag what looks anomalous. They send a command back. That command takes another 22 hours and 38 minutes to arrive. Then they wait 22 hours and 38 minutes again to see what it did. That is the rhythm. 2 days minimum between asking a question and beginning to understand the answer. and the people who can ask the right questions are aging out. Somewhere in Pasadena, an engineer in their 70s is reading a printout of telemetry from a machine they helped build when they were 30. The machine is 15 billion miles away. It is showing them numbers that do not match the predictions they wrote down in 1977. And they know that they may not live long enough to find out what those numbers mean. The spacecraft is not the fragile thing. The fragile thing is the chain of human minds still able to interpret what it is telling us. And that chain is shorter every year. There is a version of this story where the anomaly is real, the data is sound, and humanity simply builds another probe to confirm it. That version is not available, not in any meaningful time frame. The Johns Hopkins Applied Physics Lab has been working on and off on a concept called Interstellar Probe, a purpose-built spacecraft designed to reach about 1,000 astronomical units in roughly 50 years, 6 times further than where Voyager 1 sits today. The cost estimate is north of $3 billion. The mission timeline, from approval to launch, is at least a decade. The mission lifetime, from launch to crossing Voyager's current distance, is at least another 2 decades after that. If approved tomorrow, the spacecraft would not match Voyager's current position until the late 2050s. To exceed it, the 2070s. Most of the people watching this video will not be alive when that data comes back. The anomaly we are talking about right now will not have a second opinion in your lifetime. The anomaly Voyager is showing will not have an independent confirmation for at least 40 years. Not because the science is hard, because the institutional appetite to build the mission does not exist. NASA's planetary science budget is finite. It is being spent on Mars, Europa, Titan, the lunar return. A mission whose primary payoff arrives after most of the people who funded it have retired or died is the hardest possible thing to sell to a Congressional Appropriations Committee. There are no votes in a probe whose results no living senator will see. There is a deeper problem under the budget problem. Voyager runs on plutonium-238, the radioisotope that powers the RTG. Plutonium-238 is not something you can buy. It has to be produced in a small number of nuclear reactors. The United States stopped producing it in 1988. Production restarted at low volume in the mid-2000s. The current rate is enough for roughly 1 deep space mission per decade. Every other future probe is competing for the same fuel. The fuel constraint is, right now, the hardest physical limit on what humanity can actually launch. Then there is the listening problem. The Deep Space Network, those 3 antenna complexes in California, Spain, and Australia, is the only infrastructure on Earth that can hear something the size of Voyager at Voyager's distance. The network is aging. It is overbooked. China is building parallel infrastructure. But the actual ear that listens to Voyager is a Cold War-era American system being asked to keep working long past its design life. So we have one data point telling us something is wrong with the model, and no plan to get a second data point before most of the people watching this video are gone. I want to be careful here. I am not accusing NASA of lying. I am not accusing the Voyager team of hiding anything. The truth is more uncomfortable than a cover-up, because a cover-up is a thing you can expose. What is happening with Voyager is structural, and structural problems do not have villains. Read a NASA press release about Voyager carefully. The spacecraft continues its journey into interstellar space. The mission is ongoing. Anomalies are engineering challenges. The trajectory is described in terms of distance and velocity, never in terms of model residuals or unexplained accelerations. The press release is not false. Every sentence is technically accurate. It is also a sentence chosen from among many possible sentences because of what it leaves out. Compare that to the language inside JPL. The trajectory ephemeris files are revised. The tracking residuals are logged. The internal discussions are far more honest about what is and is not understood. The institution is not hiding the data. The data is on the internet. The institution is hiding the meaning of the data by phrasing every public statement in the most reassuring way the facts will allow. Here is why this happens. Every NASA mission is in competition for a finite congressional appropriation. The way that appropriation gets decided is political. Senators and representatives, most with no scientific training, look at headlines and approval ratings. A press release that says Voyager continues to make history is fundable. A press release that says Voyager's trajectory residuals suggest our gravitational model may be incomplete at large scales is not. It is, in fact, the kind of statement that gets a budget cut, because it sounds like the program has failed even when it has done the opposite. It has succeeded so well that it has reached the limits of the physics that designed it. The historical parallel is the Mars Climate Orbiter. In 1999, the spacecraft was lost because one team used metric and another imperial units. The initial press communications described it as a navigation error. The full story came out over the following months, in fragments. The agency did not lie. They softened. They phrased. They waited. That is not malice. That is media management. The narrator is not telling you NASA is corrupt. The narrator is telling you that any institution that has to justify its existence to politicians will phrase its findings in the language most likely to keep it funded. That is survival. And the predictable consequence is that the public version of any scientific story will always lag the internal version, and the lag will be longest on findings most threatening to the institutional narrative. If the institution that built Voyager is structurally unable to say the trajectory is unexplained, who is supposed to say it? Now I want to widen the frame as far as it will go. The story stops being about a spacecraft. The story becomes about what the spacecraft might be allowing us to see. If Voyager is being pulled by something the model does not include, the candidate explanations are not small. They are some of the largest open questions in physics. The first candidate is mass. Specifically, undiscovered mass in the outer solar system. The Planet 9 hypothesis, proposed by Konstantin Batygin and Mike Brown in 2016, suggests that the orbital clustering of certain trans-Neptunian objects can be explained by a planet of about 5 to 10 Earth masses, sitting at 400 to 800 astronomical units. That planet has never been directly observed. The hypothesis remains contested, but if it exists, its gravitational pull would be exactly the kind of small, persistent tug that could show up as an unmodeled acceleration on a probe at Voyager's distance. We would not have to invent new physics. We would only have to admit there is something in our own backyard we have never seen. The second candidate is gravity itself. Modified Newtonian dynamics, MOND, was proposed by Mordechai Milgram in 1983 to explain why galaxies rotate faster than their visible mass allows. The standard answer is dark matter, a substance searched for 40 years and never directly detected. Every direct detection experiment has come up empty. MOND offers a different answer. It says gravity behaves differently at large scales and low accelerations. If true, the same modification that explains galaxy rotation should produce small anomalies in spacecraft trajectories at the edge of the solar system. Some MOND proponents have pointed to Pioneer's drift as exactly the signature their theory predicted. Most physicists do not accept this. The debate is unresolved. The third candidate is the medium itself. Voyager has been measuring the density of the interstellar medium directly, and what it has found has surprised the modelers. The density is higher than predicted in several regions. A denser medium would produce more drag. Drag, at Voyager's velocity, is a tiny force. But tiny forces, integrated over decades, do exactly what we are seeing. And then there is the fourth category, which is honest. There may be something we do not yet have a name for. Every time humanity has built an instrument sensitive enough to detect a new force or particle, it has found one. Neutrinos, predicted in 1930 and detected in 1956. Gravitational waves, predicted in 1916 and detected in 2015. Dark energy, inferred in 1998 and still not explained. The history of physics is the history of building better instruments and discovering, repeatedly, that the universe contains more than our equations described. If our gravitational model is incomplete at 160 astronomical units, it is incomplete everywhere. Voyager was supposed to be the end of an exploration. It might be the beginning of an entirely different one. Here is the verdict. Voyager 1 is not lost. It is not failing. It has not been hijacked by aliens. It is not the subject of a conspiracy. It is doing exactly what a properly built scientific instrument is supposed to do. It is revealing the limits of the model that built it, and it is forcing the people who built that model to confront the fact that those limits exist. Let me stack the proofs one more time. The Pioneer precedent. 2 spacecraft built in the same era showed an unexplained sunward acceleration for 30 years. The case was officially closed in 2012 with a thermal recoil explanation that depends on assumptions nobody can verify. The closure was institutional, not physical. The 2012 Heliopause surprise. NASA expected the interstellar magnetic field to be oriented differently from the heliospheric field. It wasn't. That finding has never been fully explained. The 2018 Voyager 2 crossing confirmed the same pattern. 2 crossings, 2 anomalies, 1 silence. The unmodeled trajectory residuals. Recent reanalyses of Voyager Doppler data are showing small, stubborn, sunward residuals. Same direction as Pioneer, same order of magnitude. The institutional softening. The agency phrases every public statement in the language most likely to keep the program funded. That is not corruption, that is survival. The press release is a marketing document. The ephemeris file is the physics.